The University of Chicago's General Social Survey is the nation's most important social science sample survey. For reasons known only to social scientists, the GSS regularly asks a random sample of people their astrological sign. Here are the counts of responses from a recent GSS. So Aries is 321, Taurus is 360, Gemini is 367, and so on, right? If the births are spread uniformly across the year, we expect all 12 to be equally likely. Are these data inconsistent with that belief? Carry out an appropriate test to support your answer. If you find a significant result, perform a follow-up analysis. So we want to perform a test at the alpha equals 0.05 significance level so the null hypothesis is each one of these is equally likely. So that's 1/12, which is 0.083 for all astrological signs versus the alternate hypothesis where at least one of the piece of eyes is incorrect. So they don't follow this equally likely, right? Okay, so the plan, we should use a chi-square goodness of fit test if the conditions are satisfied. So a random sample was used, the survey, right? General Society survey. Large sample size, so since the sample size is, so these are the counts of all the ones we got from the survey, and it turns out they turn out to be 4,344. We multiply that by 1/12 because that's the expected count in each category, and that's going to be 362, which all of them are bigger than 5, right? And the independent, we can assume that there are that 4,344 is less than or equal to 1/10 of n, where n is the number of U.S. residents, right? So all the conditions are met. So here's the test statistic. Remember, for chi-squared, it's going to be the actual count from the sample minus the expected value for that specific one over the expected, right? Well, of course, squared over the expected. And we do that for every single one, right? So remember, Aries was 321, Taurus was 360, right? And then the last one, Pisces, was 355, right? Or Pisces, I don't know. Pisces was 355, right? So doing that chi-squared statistic, it's going to be 19.762 with a degree of freedom. So there's 12 signs minus 1, which is 11 degrees of freedom. As you can see, I got the p-value to be between 0.025 and 0.05, right? So, well, I'm going to show you how I got that from the table. So remember, it was 19.762. So 19.68 with a degree of freedom of 11, right? So as you can see, it was 19.7, right? 7 something. So it's going to be between 0.025 and 0.05, which is what I got, right? So since the p-value is less than alpha, which is 0.05, we reject H naught and conclude that the 12 signs are not equally likely. So here's the follow-up analysis. The breakdown of chi-squared statistic is, so this is the chi-squared statistic. We can see that there's a big jump here and a big jump here, right? So from this, we can see that the largest contributors statistic are Aries and Virgo. So this is Aries, right? And Virgo was the 1, 2, 3, oh, I guess 1, 2, 3, 4, 5, 6, the sixth one, right? 1, 2, 3, 4, 5, 6. Yeah, Virgo. And as you can see, Aries is significantly lower than our expected. Remember, our expected was 362. So it's a lot lower. And Virgo is a lot bigger. So they're just contributing in different ways, right? To that chi-squared statistic. There are fewer Aries and more Virgo than we would expect, which is what I just said, right? There are also more Libras and fewer Scorpios, right? So Libras were, so Aries and Virgos, right? And there's a lot more Libras than we expected and a lot fewer Vertigos and Sagittarius, I don't know, right? So that's what it says here. Fewer Scorpios and Sagittarius than we would predicted. And then here is a list of all these, right? So we can see Aries is between March 21st and April 19th, so that was pretty low, right? So the big ones, remember, was Virgo. So there was a lot of births between the 23rd and the 22nd. Um, remember, another one that was big was there were more Libras. So Libras was September 23rd to October 22nd. And then let's see, Gemini, were there a lot of Gemini than we expected? So there was about the same, right? But there were more Cancer. Well, there is more Geminis than we expect, but not by much, right? And there are more Leos. So it definitely seems like, based off of this right here, this suggests that there are more people born in the late summer and early fall months than we would predict if all time periods were equally likely, right? Because there's quite a bit in, well, there's more than expected in, was there more in Leo? Uh, Leo. Yeah, there was more than we expected in Leo, right? So in all these in late summer and early fall months, there were more than we expected, right? So that was from our analysis.